This video is for topic 5.11, catalysis. The objective for this topic is to explain the relationship between the effect of a catalyst on a reaction and the changes in the reaction mechanism. So let's talk about what a catalyst does. A catalyst must do one of two things. It must either increase the number of effective collisions. So we know that in order for a reaction to happen, the particles have to actually collide. So if we can increase the number of collisions via a catalyst, it's doing what it's supposed to do, which is to make the reactant or make the products a little bit more favorable. The other way a catalyst can work is to provide a pathway of a lower activation energy. So if a reaction has an extremely high activation energy, we can oftentimes put in or include a catalyst which will lower that activation energy. So it's either going to change how the particles collide or change the energy required to make the reaction happen. The net concentration of the catalyst is always constant. So it's going to be consumed and then later regenerated. So it ultimately doesn't play a role in the stoichiometry of the reaction. It plays a role in the kinetics and how the reaction is going to proceed, but it doesn't change the amount of product that would be made in the reaction. So one of the ways that a catalyst works is by binding. So a catalyst can bind to a reactant to do one of two things. So it either puts it in a more favorable orientation. So if we think back to our collision model, not only do particles need to collide with enough energy, they also need to be able to collide in the correct orientation. So catalysts can sometimes bind in order to force the particle to orient in a way that is more favorable, or it can bind to lower the activation energy. This creates a new intermediate, so a different intermediate than the reaction if there was no catalyst. A common example of this is in enzymes. So enzymes involve binding to provide a more favorable orientation, and we also see this in acid-base catalysis. The other way that catalysts work is on the surface. So this is where a reactant or an intermediate will bind to the surface of the catalyst, and it will create new or different elementary reactions. So it alters the way in which a reaction mechanism is going to take place. A common example of this is in, so we'll see solid catalysts, and so a piece of metal is a common example. Platinum is a commonly used catalyst, and that allows the reactants to bind to the surface, which changes the elementary reactions.